So good morning students. Now we are going to see the finite state machines. Just as a recap of finite state machine, it has some states with the inputs and the outputs. Okay, this is state transition diagram. From the state transition diagram, how the circuit is going to be transformed. The state can be represented here flip-flop. The state can be represented in terms of flip-flops. The flip-flop have present state and the next state. The input, the art can be do in the form of inputs and the outputs. Okay, this output. So the input and output can be obtained through the combinational logic circuits and the flip-flops. This is about the simple definition of how the state diagram can be transferred into a circuit diagram. Here we have Mealy machine and Mealy machine. Mealy. What does mean by Mealy machine? Mealy machine is nothing but it generates output based on only the present state. Okay. The output generated based on the present state. This is the output. Based on the present state, output is generated. The Mealy machine is the output generated based on the inputs, present state and the next state. Okay, so everything interpreted to change the output. Here, this is the state. The state can be given in the form of flip-flop. This arc input and output, you have it here. Okay, so the Mealy machine is the out depending upon present state and the input. Here, the output depending upon only the present state, only on the present state. So that is Moray. That is output based on only the present state. Here, the output depending upon present state and the input. Okay, so these are the things are very important. The next slide we can see the edge detector example. So edge is nothing but it's going to be found depending upon the what type of edge the output is going to be change. Okay, here bits are received one at a time, one per clock the bits are received. This is the input. This is FSM block diagram. Input is this one. We are going to calculate the edge going to be detected. So design a circuit that asserts means high its output for one cycle when the input bit stream changes from 0 to 1. If the input changes from 0 to 1, okay, this is input, so the output is high. Whenever it changes, the output must be high. So this is the meaning of the statement. Now we can design the circuit first using Moray machine and the Mealy machine. So this is the state diagram of Moray. Okay, first 0, that is the input changes from 0 to 1. Okay, if the input is 0, there is no output. Okay, if next input is given 0, it retains the same state, output will be 0. If input is 1, okay, there is a transition change from 0 to 1. Okay, so that is 0 to 1. What will happen? The output is 1, so automatically the output is 1. Okay, this one. This is the condition. If again when I give 0, input to 0, what it will happen? In 1 to, this is 1 to 0. What the output will be 0. Okay, this is first this change. The next one, again the input is provided as a 1 continuously. If the input is 1, what it will happen? There is a, that is 1. The output is 0. then it will output is 0, because only the statement says that whenever there is a transition from 0 to 1, the output is 1, otherwise it will be 0. Okay, that is the condition here. You look at that. This is input, this is input, this is input. Okay, when there is a change from 0 to 1, the output is 1, that is given here. Okay, if this is single cycle, here input is, this is 0, this is 1, this is 1, this is 0, this is input. If continuous 1, again the input is 1, what will happen? The output change to 0. Okay, then this process will be here. So you look at this one, the input is 1, output is 0. Again, if you give input is 1, it will retain as a 0. If the input is 0, what will happen? It will go to the output 0. Okay, so this can be given in the form of the state diagram. Now we can see the state table. The state table is you do the input, present state, next state, output. Okay, if the input is 0, present state is 0, 0, that is state you take it. 4. What is the next state? It will retain 0, 0. What will be the output? 0. Then if the input is 1, there is a change. Okay, input is 1, the state is 0, 0, the next state 0, 1, but the output will be 0 because there is a no transition. If there is a transition, this is 0, 1, the present state is 0, 1, this state. Now the next state will be 0, 0. Here the input is 0, the output is 1. Similarly, if the input is 1, the state is 0, 1 during this state. Okay, so what is the next state? Next state it will go 1, 1. So the output is 1. Similarly, if you come to this one condition, if the input is 1, the state is 1, 0, 1. Okay, if the input is 0, it will go to next state 0, 0. This is the next state for this case. Okay, if it is a 1, it will retain the same state. The output becomes 0. So the state diagram can be represented in the form of the state table. So this one, using the Karnaugh map, get the reduced expression. Okay, because you have the state, input, present state. Find the next state using the Karnaugh map. Get it. Similarly for the output, draw the logic diagram. This is about the Moray machine. For Mealy machine, the output depends not only on present state but also on input. You come to here 0. If the input is 0, what will happen? It's not an edge detector, the output will be 0. If input is 1, there is a change, so the output is 1. Similarly, if input 0, output 0. If input 1, output 0. Okay, here that 0 you take it as a state 1, 1 you take it as a state 1. If input is from the state diagram, draw the state table. So if you look at that is next state similar as the input. Output is inverted of the present state. Okay, so using this, draw the diagram. This is about meaning. So edge detector timing diagrams. This is the clock. Input is given. This is for Moray model. This is for melee. So solution A, both edges of output follow the clock. Look at the clock, the both edges of output. So whenever the clock comes, it follows. But B, output rises with input rising edge and is asynchronous with respect to the clock. Output fails synchronous with the next clock. Okay, so this is about the difference between melee and mobile. So this is the Verilog code for edge detector example. So using this state diagram, we have to write down the Verilog code. This can be implemented by using the similar. Thank you.